You doing math? I got you. All right, so today I'm gonna show you how to add and subtract fractions. But before we get into that, I want you to look at each fraction and I want you to understand that you can look at each fraction and you can name it a certain way. Like for example, if you see the very first one, that says 1/6. The denominator is used to name a particular fraction what it is. Like 1/6 basically means there are 6 slices. So I'm gonna go ahead and draw myself a slice. First I'm gonna draw a circle. So I'm gonna draw a circle and I'm gonna go ahead and give myself 6 slices. You'll notice I created 6 slices. And from those 6 slices, this basically says 1/6. So I'm gonna go ahead and shade in one piece. I'll make that yellow. So that's what that piece looks like. So now that I got a visual of 1/6, what I gotta do? Second of all, this right here, it says 4/6. So same concept.
Yo, your head looking like a circle.
6 different pieces. So now since I have 6 different pieces, I'm gonna shade in 4 because that's the number at the top. So I'm gonna say 1, 2, 3, 4. Okay, so now what I can see is that I have 1/6 plus 4/6. So what I'm talking about is the size and how big each piece of the pie is. And so I can go ahead and add and say, if I take 1/6 and add it to 4/6, I'll have 5/6. You'll notice the denominator stays the same because the denominator is used to help me name the fraction. The fraction doesn't change. Better yet, you see this where it says same denominator? Well, we need to understand that these are considered like terms. Because they're like terms, I can actually add or subtract them. Because the denominators are the same, they're considered like terms. And you'll see that come up at a later point. So if you look at the one at the bottom, you'll notice it says 2/8 plus 4/8. Instead of drawing a model, what I could do is I can actually write it out. And this is what I mean by that. So it says 2/8, so I'll go ahead and say 2/EIGHTS. So that would basically be read as 2/8 plus 4/8. And again, I don't need to do anything with any fraction, right? Just by simply looking at this problem right here, 2/8 plus 4/8 will give me 6/8. This reminds me of 2 apples plus 4 apples equals 6 apples. The denominator stay the same, and so the denominator stays at 8. And then all you gotta do is take the numerator and add them. So we have 2 plus 4, which is 6. And so you'll notice 6/8 and 6/8, they're the same thing. Why? Because the denominator
helps name the fraction.
So all we're doing is adding like terms, right? All we're doing is combining like terms. And in this particular case, the like terms are 8s. That's the size of each piece. But one thing about that is that's not simplified. And you can actually simplify that. In order to simplify, all you gotta do is whatever you do to the top, you do to the bottom. And so because both numbers are even, I'm gonna go ahead and cut both of them in half. So I'm gonna do half of that one and half of this one. And as soon as I do the half of each one, half of 6 gives me 3, half of 8 gives me 4. And you'll notice 3/4 is simplified. So this would be my final answer. That's on the addition side. Subtraction works the same way. What am I looking for? I'm looking for this right here. I'm looking for like terms. And how do you identify like terms? It's the denominator. The denominator, if the denominator is the same, then it stays the same because I'm just adding the pieces together. So if you look at this one, imagine you had a cake and you had 5 out of 7 slices, meaning there are 7 slices that somebody sliced it into, and you got 5 of them, right? And here, somebody came and ate 2 of those slices. Well, if somebody came and ate 2 of those slices, the denominator being 7 just tells us that they are like terms. Like terms in the sense of what? The size of each slice of cake are the same. So we have 5/7 minus 2/7, which will give us 3/7. And that is our final answer. That is a simplified fraction. Again, similar to the one at the top, the one at the bottom, this cake was split into 12 pieces. And there are 11 pieces. And if your mom came by and said, "Ooh, I'm gonna grab one," and after eating that one, she's like, "Nah, I just can't stop after eating one. I gotta eat another piece." So that means you had 11/12, but your mom ate 2 slices, so now minus 2/12, right? Think about what I'm saying for the denominator. 11/12 minus 2/12 equals 9/12. Again, 9, where'd I get 9 from? I just subtracted, right? 11 minus 2 gives me 9, and then the denominator, I'm not doing anything with that because the denominator helps me name my fraction. And so 9/12. Now that is not the final answer because you can actually simplify that. And in order to simplify it, what you do is whatever you do to the top, you do to the bottom. And anytime you simplify, you want to divide. And so because this is 9 and 12, I'm going to try dividing it by 2. How do I know if it divides by 2? Well, I can count by 2s. 2, 4, 6, 8, 10. You'll notice I never say 9, so if I count by 2s, it'll never work. So then I count by the very next number, which is 3. 3, 6, 9, ding, ding, ding. 12, ding, ding, ding. You'll notice I counted by 3s, and I said both 9 and 12. So what does that mean? Therefore, I can divide both 9 and 12 by 3. So I'm going to go ahead and divide the top by 3 and also the denominator by 3. And as soon as I divide both top and bottom by 3, I'm going to go ahead and have 9 divided by 3, which gives me 3, and 12 divided by 3, which gives me 4. As you can see on a previous problem, we did get 3/4. So 3/4 is considered the most simplified version of a fraction. So this is how you add and subtract fractions. What's the most important thing? The most important thing you need to understand is that the denominators are the same. So it stays the same. Why does it stay the same? Because the denominators, we don't do math for that. The denominator's purpose is that it helps us name the fraction, right? Name the pieces. Names how big each size of each slice is.